Hello. In this video, we're going to rewrite f of x equals negative x squared plus 12x plus 3 in vertex form. The reason why I've picked this example in particular is because the a term is negative 1, and this often causes a little confusion for students. But it's nothing to worry about. So the first thing to notice here is that the a term is not equal to 1, and what that means is I have to factor it out of the first two terms. So let's start by writing out this function again. F of x equals negative x squared plus 12x plus 3. So what this is going to mean is that I'm going to factor out the negative 1 and now that I've factored out that negative 1 from the first two terms, I can go through my process of completing the square. So I'm going to find my magic number. And my magic number is equal to b over 2 squared. Notice every time I write out that formula, that is a way that helps me memorize it. Negative 12 over 2 is negative 6. Negative 6 squared is equal to 36. So therefore, we end up with negative x squared minus 12x. And I'm going to say plus 36 minus 36. Notice we always do the plus term first, then the minus term. Plus 3. And now if I've done this right, these three terms should make a perfect square, and in fact they do. So this factors to negative x minus 6 squared minus 36 plus 3, and now we're going to multiply the negative in to give me minus x minus 6 squared plus 36 plus 3. Watch that sign change there. Minus and minus is a plus, which gives me minus x minus 6 squared plus 39. Now at this point I want to make a couple little points. One is, if we were given this quadratic in this form, we would confidently be able to say that it opens down because of the negative term right there. Let's see if we can extend that same type of confidence to a quadratic in standard form. So we notice that it has a negative leading the x squared term, and that essentially I factor that negative out and then eventually have to multiply it back in, so we know that that negative is going to end up sitting out in front of the actual perfect square component. So that means that if the a term in standard form is negative, we can state that this quadratic opens down, which is a nice little observation to have in our bag of tricks. Now let's pretend you were doing this and you wanted to check to see if this was right. Well, you have this wonderful tool called GeoGebra, and what I have here, let's see if I can slide this over just a little bit, is my function which I've graphed, negative x squared plus 12x plus 3. Remember, f of x here and here represent the same function, so the picture should be exactly the same. So what I'm going to do to check my work is I'm going to come into GeoGebra, I'm going to make a new function called g of x, and I'm actually going to type it in vertex form. Before I hit enter, I'm going to look at this. It opens down, so I feel pretty good about that. The vertex is somewhere is the midpoint between these two roots or x-intercepts. That looks about 6 and 39. So I'm feeling pretty good about this, and if I hit enter, I don't get a second graph showing up because that second graph has been graphed directly on top of the first. So now I've proven to myself that this form of the quadratic relationship and this form of the quadratic relationship both graph the same picture, meaning they're matching. I hope that helped.